Tech Nuggets, basic workstation and network diagnostic tools. Today's basic diagnostic tools, we're going to talk about our ping and traceroute. And they're basic tools we use when we want to be able to see a little more about our network ecosystem that we're living in. And it's more than deriving information from our own workstation about what its IP address is or its settings are. Once we're confident in that information that, yeah, it's got an IP address and yeah, I think it should be working and it's got all the things it needs, much like, does my car have tires? Yes, it has tires. Okay, well, now let's go see what the road looks like. Ping and traceroute begin to tell us more about the world out there. So ping is available in Linux and Windows and is a very basic, very old utility that's been around for a long time. It has a really basic function. It derives its name from a sonar ping. So we can throw packets out there and we'll throw ping packets at a destination. And if the destination can see those packets, most often it will respond. And it will bounce packets back to us. And so it kind of works like a sonar ping. And we can time that ping and tell what the latency is. So we might talk about ping times or lag times. And oftentimes those are ping times that we measure. Sometimes firewalls will block those kind of ping packets, and so you'll throw ping packets out there and they won't go anywhere. But most things will respond to ping, at least inside your own network. You would be able to ping your neighbor. Very useful to know. Okay, I've got an IP address. Can I ping my neighbor? Yeah, I can ping my neighbor. There's no firewalls on my neighbor's piece of equipment. I should be able to see ping packets back and forth. It's not a terribly useful piece of information when we want to ping, say, Google. Lots of different network equipment, and the network ecosystem is quite a bit larger when we want to do that. And we'll use other tools to try to get a little more information about that. Ping is often used for local network, maybe can I see my ISP kind of stuff, so I can diagnose kind of closer things. Our second tool, Traceroute, is used to do a little bit larger network diagnostic. It measures all the routers between you and a destination. They're called hops. So if you were to trace route from your workstation to Google, you would see a variety of hops. And I can't tell you how many there'll be because it's different depending on where you are in the network and where Google is in their network and that kind of thing. So a trace route that we'll see here in a little video in a little bit might look very different than the trace route that you'll see. Keep in mind that traceroute in Linux is spelled all the way out, and traceroute in Windows is spelled traceRT. There's a historic reason for this that I won't bore you with, but it is worth knowing. Traceroute also comes with two options, and they're usually on, especially in Windows. This option is on where we're going to do name lookups, and we'll have another video that talks about DNS and name lookups. In this case, it's useful to know that while it's doing these name lookups, things can appear to be very slow, can take a long time. And in some of our lab setups, we won't have name servers to be able to do name resolution with. And so the timeouts can be quite lengthy, where I don't really care about the names. I just need the traceroute, and I can tell by IP addresses where we are and where we're not, especially in a lab environment that maybe you've created and you're not worried about that kind of stuff. So at the bottom, we've listed the command line options that you would need to turn off name lookup. And in Windows, that will be -D, and in Linux, it will be -N. In the video where I demonstrate traceroute, we'll talk a little more about it, and you'll get to see that back and forth. All right, well, this is my Ubuntu box, and we're going to do some pinging with it. So I'll be pinging using the ping command, also using a host name. We use google.com since most people know what google.com is. And we can sing, I typed ping, I'm google.com, and it's out there. This type of ping on this version of Linux will ping forever until we hit Control-C. And you can see I hit Control-C there and it stopped the ping. But we're sending 64-byte packets, and it resolves an IP address. 172.217.5.14, that's its IP address. And we can see that it's got a round-trip time of 24 milliseconds. And they vary just a little bit as we go along. As you can imagine, a constant stream of packets will have slightly varying times as it crosses the network. It's not a fixed thing. And at the bottom, we get sort of a minimum, average, maximum report on how did it go for all the packets we sent in the entire run of that. And I'll flip over here to Windows, and you can see I've done it already. I did ping, and it pings google.com, which it resolves to an IP address, and then we get ping times. You can see they vary, and then Windows here, however, only does 4 ping packets. It There are settings to make it do infinite or a fixed number of ping packets, but standard just type ping in Windows gets you 4 ping packets. So it's worth knowing. We'll go back to Linux, and I will do ping with an IP address. 8.8.8.8 is one of Google's public DNS servers, so you can see no name lookup happens as I'm using an IP address, so it will go directly only to that IP address. So in many cases, if you're trying to be specific on how you ping, you'll want to use an IP address, not a host name, because an IP address can be one specific place, whereas a host name can be a little more slippery. It can be a couple different places, depending on how they played games with ping to get it to do that, or I'm sorry, DNS to get it to do that. And you can see I hit Control-C, and I got the same report, minimum, average, maximum. We'll go up to the Windows 10, and we'll do the same thing. 8.8. And you can see here that it's doing the same thing. It'll do 4 packets, it'll ping, it'll finish. Ping's a pretty easy tool, gives some basic connectivity of what's going on, really useful for understanding can I see anything in the world? Is my Ethernet card working at all? We generally use it to ping our neighbor. And by neighbor, I mean somebody that's in the same network with us or in the same subnet with us. It can be used to do more extensive testing, like I pinged Google, but we really don't get any information about what's in between here and Google. Other tools in this video will talk about those kinds of things. Alright, well, the next tool on our list to look at is Traceroute. Traceroute's one of the first tools we're going to look at when we want to understand what's going on between me and the far end, whatever I want to look at. And that far end can be close, it can be my neighbor like we talked about with ping, or it can be far away. I want to know what's going on between me and Google, or me and, you know, the other side of the world. The farther away it gets, the more network hops there are, and that can get kind of interesting. But Traceroute will show us some of that. And we're going to start off. Traceroute's kind of an interesting animal. It's designed and built differently on each operating system. So, and by that I mean there are a couple of different types of packets that can be used to accomplish the Traceroute functionality. Windows uses one kind, Ubuntu uses another kind, Mac OS uses a third kind, and they're all slightly different. They do the same job, but sometimes they do the job in different ways, and you'll get slightly different results with them. In broad strokes, you should get relatively the same answers. In specific terms, sometimes the Windows one will be blocked by a firewall and the Ubuntu or the Mac one will work just fine. Why? Lots of different historic reasons why. My suggestion is try several of them if you get stuck on one. Don't let one stop you, move on to the next one and try another one. Alright, so we'll start off here with Traceroute, and again we'll go with traceroute.google.com, and you can see it goes through. Each one of these is considered a hop, which is we go from local me. We remember earlier my IP address was 10.101, so we look here on the first line and we can see, hey, this person's IP address is very close to mine. It in fact winds up being my gateway, which is why it's labeled gateway. That's the machine that talks in my network and outside. Each one of these is a router, meaning it routes packets. It goes from one side of the network to the next network, and it passes packets along like a fire brigade is passing buckets of water. It goes from one person on one side to another person on another side. Interestingly enough, you'll see in here in the center, there's several hops where nothing happens. Those are people that have decided not to report anything. Traceroute is kind of a voluntary thing. You can turn it off on your router and it won't respond to requests. The other thing you'll notice about this is it's kind of messy. There's a bunch of host names, there's a bunch of other stuff going on. Sometimes when we do Traceroute, especially in a lab environment, we don't have the facilities to look up names, or maybe no names are set for our IP addresses, and that's going to slow things down. Traceroute's going to go out there and try to resolve those IP addresses to host names so it can show it to you, but there's a big long timeout while it waits, especially if there's no information to show. And down here at the bottom you can see there's several that had no host names. There was nothing associated. There's no name for that IP address. In that case, we can do this. We can do a -N in Linux. It's -D in Windows, it's N in Linux. I couldn't tell you why, I didn't write it. And you can see it's a little quicker. Now in this case I have name server access, so everything should resolve rather quickly. But with the -N option you can see all I see are IP addresses. So I can see it's going to my local gateway, and then it's jumping through a variety of other hops before it gets to its destination. And the destination, Google has a lot of different servers on the other end. The IP address, I believe, is pretty similar to what we were looking at before when we were doing ping and things like that. If you flip over to Windows, we'll take a look at it there. So Traceroute, and we'll do google.com. And this one's a little slower. It uses a different packet style to go get those answers. You can see it's going to the same place, but it's taken a lot longer to get there. And you're going to ask why? That's because in this Traceroute implementation, it's doing 3 checks. So it's actually sending 3 packets for each one. And you can see it's doing 3 checks. That's what the 3 columns are. And at the end, it'll give you the averages of how did it find those things. These columns are additive. So as we go along, they'll get bigger and bigger and bigger. I believe, as we do that. So it'll be longer and longer. You can see we've hit the number 10 hop, which tells us, hey, I'm not telling you anything about it. Sometimes when we look at host names, we can tell things about what's going on. This is going through Cincinnati, right? That's what Cincy.net would be. It's an N0.2 connection, which if you're up on the infrastructure of the internet, you'll know what that means. You can see other things here. This is Athens and Columbus and other places that the packets are bouncing through. If we get to the other side, we can see there's no name lookup at all that goes with these, which is what we saw in the Linux lookup. We're just going to get IP addresses. But it's still trying, and it's wasting a bunch of time timing out, waiting for that to happen. And at the end, we get 1. All right, we'll also do it without name lookup, which is a -D option in Windows. And it will go somewhat faster. It's still going to do the 3 tries, but now it's not going to stop and try to do name lookup for all those kinds of things. So you're going to notice it's going to plow right along. The ones that don't respond, it says request timed out. It will wait a certain amount of time. Maybe our packet got dropped or something, so it's going to wait a certain amount of time trying to do that, which will slow everything down. Again, in a lab environment where you're really sure all those different pieces are up, you probably won't run into that. If you try to trace route across the internet, yeah, you'll probably see more of that kind of stuff. That's not unusual. You can see here, it's going to hit the end here. 16 hops is actually not that far. Things that are far away tend to be 35, 40, 50 hops. It gets bigger every year because the internet gets bigger every year.